Lesson 13. I will decompose to smaller units once using the standard subtraction algorithm. As we get started today, I will explain to you what it means to decompose to smaller units, and I will also explain to you what a standard subtraction algorithm is. Alright, so turn your math journals to the next blank page, and I want you to fill in today's date, and I want you to write Lesson 13 subtraction, and when you're ready, press play. The first thing I want you to put in your math journal today is I want you to write this math problem, 4,259 minus 2,171. But instead of writing it horizontally or side to side, I want you to come up and I want you to write it vertically. So you're going to write this going down. This means vertically. Okay? Alright, so beside that subtraction problem, I also want you to draw this tape diagram. And then I want you to draw a long line over the top and then two shorter lines over the bottom, okay? All right, next. This tape diagram is going to represent our subtraction problem. So at the top we have our whole. So the whole is the large number, 4,259, and 2,171 represents a part that we're taking away, and the other part, or part A, is just going to represent what is left when we take away 2,171. All right, now, the next thing I want you to draw is I want you to draw a simple sketch of a place value chart. Notice that we labeled it ones, tens, hundreds, thousands. It's okay if you choose to use digits instead of words. You can come in here and just put tens, hundreds, thousands, etc. But now we're going to model our whole. Our whole is 4,259. So we're going to put 4 thousands, 2 hundreds, 5 tens, and 9 ones. Now that we have that model, 4,259, now we're going to determine if we're ready to subtract. So when I go back up here and I look in the ones place, as always, I'm trying to take away 2,171, so I'm going to start with the ones. So I'm looking, I'm saying, okay, can I take away 1? Obviously. And I know you're probably thinking, Ms. James, I already know how to subtract, but it's really important that you understand the basics of subtracting, not just, oh, 9 minus 1 is 8. It's really important that you understand why this works. So we can take away 1. Alright, so over in your subtraction problem, I want you to go ahead and put an 8, because when you take away 1 from 9, you're left with 8. Now we're going to look in the tens place. In the tens place, it says that we are trying to take away 7 tens, but we don't have 7 tens. We only have 5. So before, we've been talking about how you can take 10 tens and bundle them together to make 100. Well, if you are unbundling, it's called decomposing. So we're going to take one of our hundreds and we're going to decompose it. That means we're going to go to the right on the place value chart and we're going to break it down into 10 tens. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 15 tens. Okay, that looks like this. Now I can take away 7 tens. 1, 2, 3, 4, 5, 6, 7. I'm left with 1, 2, 3, 4, 5, 6, 7, 8. Now in your standard algorithm, this is what it looks like. Your 2 became a 1 because our hundreds went down to 100, and our 5 became a 15 because we decomposed. It's really important that you understand that. That it's not just the 5 becomes 15, the 2 becomes a 1. Once you understand why that happens, you won't ever wonder to yourself, when does a 0 become a 10 and when does it become a 9? Okay, now, we are ready to take a look at the hundreds. We're only taking away 100, so that's easy, no decomposing. So 1 minus 1 would be 0. And then we're taking a look at the thousands. We're taking away 2 thousands. So 4 minus 2 thousands is 2 thousands. So our answer is 2,088. So the value of A in our tape diagram will be 2,088 because when you put these two parts together, you get this whole. So what number could be added to 2,171 to result in the sum of 4,259? answer is 2,088. You could add 2,088 to 2,171 to get 4,259. Okay, we're going to do one more. Bear with me here. So you may need to turn to a new page, I don't know, but I want you to copy this subtraction problem. 6,314 minus 3,131. Remember, I want you to copy that vertically, not horizontally. I know on the document that you're looking at, it's horizontal, but I want you to write it vertically. So when you copy this, you're going to write it up and down. Okay? Okay, I also want you to draw this tape diagram again. And this time, take a look at our subtraction problem, and I want you to think to yourself, what is the whole? What would we label at the top? And we would actually label it 6,314. Our large number is the whole. So what would be the part of the whole that we know? The part that we know would be 3,133. So I want you to label that. And now what we're trying to figure out is B. So when we take 3,133 away from 6,314, we'll be left with this value. Okay, so now let's get started. So I want you to draw another place value chart, just like the one that you see here. And we are going to model our whole, which is 6,314, because that's what we're going to be taken away from. So it's really important that we model that. So once you get your place value chart drawn, I want you to go ahead and put your place value disk on here. So I've got 6,300s, 110, and 4. Okay, so now we're ready to see if we are going to be able to subtract. So when I look up here at the ones, I'm trying to take away 3 from 4. I can do that. I can go ahead and take away 3 ones, and that's going to leave me with 1 in the ones place. Okay, so now I'm going to take a look at the tens place, and I'm trying to take away 3 tens, but I don't have 3 tens. So this is where I decompose 100, and I'm going to trade that or decompose that into 10 tens. So that's 3, 4, 8, 9, 10. So now instead of 10 tens, I come up here and I make the 10 and 11. But instead of 300s, I only have 2. So now I can take away 3. 1, 2, 3. And I'm left with 8 tens. And then I take a look in the hundreds place. I'm going to take away 1. That leaves me with 100. Take away 3 thousands. 181. Head and take a look at our problem set. You'll notice on the problem set that we're not drawing place value chart, we're just using the standard algorithm. When you don't use your place value chart or a model, this is just called the standard algorithm. Now, on your learning target today, it said we are only going to decompose once. So that's the same thing as regrouping. We're only going to regroup once. So if you feel like you know how to subtract and you don't need to follow along with me, go ahead and do a few and then come back and check. But if you'd like to go along with me, I'm going to be explaining as I go. So 5 minus 2, I don't need to do any regrouping or decomposing, would be 3. 2 minus 0 would be 2. 5 minus 0 would be 0. Or excuse me, 5 minus 5 is 0. And 7 is 4,023. 5 minus 2 is 3. 2 minus 0 is 2. 5 minus 5 is 0. 7 is 4. Minus 1 is 0. So again, 4,023. Exact same answer, right? Now, when I come to C, I'm thinking, I cannot take 7 for 5, so I'm going to have to decompose. I'm going to the tens place, and I'm going to take one of those tens, that only leaves with 1 10, and I'm going to trade it for 10 ones. So now I have 15 ones. And 15 minus 7 is 8. 1 minus 1 is 0. 6 is 2. And 6 minus 4 is 2. So I have 2,208 and 8. I'd like for you to try D, E, and F on your own, and then come back to check, and I'll explain as I answer them. 0, 2 minus 3. I can't take 3 from 2, so I have to decompose. 6 becomes 5, and this 2 becomes 12. 6 minus 3 is 9, 5 minus 4 is 1, and 4 is 4. Now come over to E. 0 minus 0 is 0. This is where kids get confused. When they get ready necessarily think it's 7, but you cannot take 7 away from nothing. So I'm going to decompose this 100. Now I have 4 hundreds, and that 100 becomes 10 tens. 10 minus 7 is 3. 4 minus 0. And subtract 5 minus 2, that leaves me with 3. 2 minus 0 is 2. Again, I have nothing. I have no hundreds, so I can't take away 5 hundreds. I have 4 thousands and decompose. Now I have 5 thousands. I have 10 hundreds. Okay, let's take a look at the next problem, problem G, and you're going to see that I already have the answer up here. But I want you to pay attention to what happened here in problem G. I was ready to subtract in the ones place, so I just said 0 minus 0 is 0. Then I went to the tens place, and I was ready to subtract in the tens place and in the hundreds place. The only place that I had to regroup was in the thousands place. So when I went to the 10,000s place, I decomposed, made the 2 a 1, and then I turned that 3 into a 13, and I was ready to go. Okay? I want you to try to do problem H by yourself, and when you're ready, press play to check. Okay, so this is problem H. And again, if you pay really close attention, you'll see that I was ready to subtract in the ones, the tens, and the hundreds. But whenever it came to the thousands, I was not ready to subtract. So I came to the 10,000s, and I decomposed that 3 into a 2 and gave 10 thousands to the thousands place, and that became 11. And then all I had to do was subtract. Okay, I want you to try problem I by yourself. And whenever you are ready, press play to see how you did. Okay, so in I, it's the same exact example or same situation. We were ready to subtract in the ones place, the tens place, the hundreds place, and the thousands. It wasn't until we got to the 10,000s that we had to decompose that 100,000 into 1 and change the 10,000s into 11. So we ended up with 98,220. So at the bottom here we have a word problem. And you notice that it says draw a tape diagram to represent each problem. Use numbers to solve and write your answers as a statement. So what number must be added to 13,875 to result in a sum of 25,884? So I'm going to draw my tape diagram. So this is my tape diagram. And my total is 25,884. So we've got 25,884. Part of this is 13,875, and I'm trying to figure out what number has to be added to this to get 25,884. So in order to find out what n is, I needed to take away 13,875 from 25,884. So I'm going to create a subtraction problem and find the difference between these two numbers. I'm copying the problem, making sure that all of my digits are lined up. I have to have my ones, my tens, my hundreds all in a line. Now, the first thing I'm going to notice that is in the ones place, I'm not ready to subtract. So I'm going to come to the tens, and I'm going to decompose the 8 into a 7, and the 4 becomes a 14. Now I'm ready to subtract in the tens, the hundreds, the thousands, and in the 10,000s. So I'm left with 9, 0, 0, 2, and 1. So my answer is the number is 12,009. Okay, let's take a look at the next page. Okay, so I want you to pause the video right here and try to solve this problem all by yourself. And as soon as you're ready, I want you to come back and I'm going to explain to you how I solved this problem. Okay, the first thing you're going to notice is this is just a little bit blurry, but I hope that you can see it's just kind of light. So after reading the problem, I noticed that Arthur Mem Fox was born in 1946. So how many years after Michelangelo was born was Mem born? So I've got 1475 here, and then I've got years for Y, and I'm trying to get a total of 1946. So I want to find out what this Y is. So I created a subtraction problem. I was ready to subtract in the ones, but I needed to decompose in the hundreds so that I'd have enough tens to subtract. And then I came over here and checked my work, And you'll notice that when I added 1,475 to 471, I got 1,946. So Mem was born 471 years after Michelangelo. Try to do problem number 4 by yourself, and when you're ready to check, press play, or if you're stuck and you don't want to know where to begin, you can get started with me. Okay, so you're going to notice that my whole in this problem was 68,025. That's how many pounds of king crab were caught. And in the first week of March, 15,614 were caught. I want to know how many pounds were caught for the rest of the month. So that's why that's why I labeled this P for pounds. So again, this is a subtraction problem. I was ready to subtract in the ones and in the tens, but when I got to the hundreds, I wasn't, so I had to decompose. That's why I changed the 8 to a 7 and the 0 to a 10. And then I came back and I checked by adding what I got for P to 15,614. And because I got my total, which is 68,025, I knew that my answer was correct. So 52,411 pounds of king crab were caught in the rest of the month. Your sentence did not have to be exactly like this, but it should have answered the question, how many pounds were caught in the rest of the month? I want you to try to do problem number 5 by yourself, and when you're ready, press play. Okay, so for number 5, my total was 118,064 miles because that's what the odometer read. And if you don't know what an odometer is the part of a car that tells you how many miles the car has been driven. So this car has been driven a total of 118,064 miles since it was built. And it says that after driving exactly 9,050 miles, this is what it read. So what did the odometer read when he bought the car? So apparently James bought this car used, and he drove it for 9,050 miles, and then his odometer said this. So we want to know how many miles were on the car before he bought it. So that's what M represents. So again, this is a subtraction problem. The only place that I had to decompose was right here in the 10,000s. I could not subtract thousands, so I had to decompose the 10,000s, and that's why this 1 became a 0 and the 8 became an 18. They gave me 109,014. I checked my answer, and it checked out correct. So the odometer read 109,014 miles when James bought the car. Okay, you are ready for your exit slip. Be sure to read very carefully and check your works to make sure that you didn't make any silly mistakes. Good luck.